Today's lesson, Chapter 7, Section 3, is Central Limit Theorem with Proportions. We're going to focus today on using the central limit theorem to find probabilities for proportions. And in order to do that, we're going to need a new z-score formula. So we're going to start with that. This is on your formula sheet. P is given to be the population proportion. P hat is our sample proportion. And N is our sample size. And if you look at the top of your notes page, it talks about how you can find population proportion and sample proportion. Anyway, we're going to deal again with probability questions that are going to use this z-score formula. So I just want to walk through a few problems with you. If you read that first question, in a certain conservative precinct, 79% of the voters are registered Republicans. What is the probability that in a random sample of 100 voters from this precinct, at least 68 of the voters would be registered Republicans? Ask you always to give me a diagram. If we read the problem again, our population proportion is 79%, which is 0.79. Our sample proportion, p hat, is 68 out of 100 voters, which is 0.68. And if I just start by putting those two things on the graph, I need to go back and read the question. It says, what's the probability that at least 68 of these 100 voters, at least 68, which means at least 68%, which is going to be 68% or more. So we're looking for the area to the right of 0.68. We know that 0.79 has a z-value of 0. We need to find the z-value for 0.68. And again, this is the formula that we're going to use. So if we substitute in what we know, p hat is 0.68, p is 0.79, and n is 100. Now, I want to stress to you the importance of putting that numerator in parentheses when you get ready to evaluate this on your calculator. So if you enter that on the calculator, you should come up with a z-value of negative 2.70. Now I want to remind you, when you look up that z-value on your z-score chart, you're going to get the area to the left of z equal negative 2.70, which is going to be 0.0035. But that's not what we're looking for. We want to know the probability that at least 68% of these voters are registered Republicans, so we need this area to the right. In order to get that, we're going to subtract 0.0035 from 1, which will give us 0.9965. So our answer to problem number 1 is 0.9965. If you look at problem number 2, problem number 2 says, in another precinct across town, the population is very different. In this precinct, 81% of the voters are registered Democrats. What is the probability that in a random sample of 100 voters from this precinct, no more than 80 of the voters would be registered Democrats? Same thing. I think it's very important when you do these probability questions that you draw a diagram. And let's go ahead and write down some things we know. our population proportion is 81%, which is the decimal 0.81. Our sample proportion is 80 out of 100 voters in the sample, which is 0.80. So we know our population proportion goes here. Means 0.80 is here. And when we say that no more than 80 out of this 100 would be registered Democrats, then we're saying no more than 80%, which means 80% or less. So we're looking for this area to the left. Again, we know 0.81 has a z-value of 0, and we're trying to find the z-value for 0.80. And again, I'm going to ask you to write down the formula that you're using to find z and substitute in what you know. So p hat is 0.80, our p is 0.81. That means the denominator is the square root of 0.81 times 1 minus 0.81 over n, which in this problem was 100. Again, put that numerator in parentheses when you enter this on the calculator. When you do, you should get a z-value of negative 0.25. Now, I want you to think about something we talked about before. There are many times that we get these two things reversed, that we're subtracting. Like instead of having 0.80 minus 0.81, somebody actually puts 0.81 minus 0.80, and when they do, they get a z-value here of positive 0.25, which we can all agree positive 0.25 can't be to the left of 0. So always kind of take a little time to make sure the z-value you calculated makes sense. All right, if we look up z equal negative 0.25 on our z-score chart, we find that the area to the left of that is 0.4013, which is our answer to this question. Now, sometimes they ask for the answer in the form of a percentage. And if they do, just remember on this problem, if we move the decimal 2 places to the right, that would be 40.13%. All right, I want to do one more problem with you. We're going to skip number 3. I'm going to leave that for you to do. And we're going to do problem number 4 together. All right, problem number 4 says it's estimated that 8.3% of all Americans have diabetes. All right, so as a decimal, 8.3% is 0.083. It says, suppose that a random sample of 91 Americans is taken. What is the probability that the proportion of people in the sample who are diabetic differs from the population proportion by more than 2%? So I'm going to want to move 2% left and right from this 8.3%. Okay. So this is going to be 0.063, and this is going to be 0.103. Now, for most people, this is going to be an easier way to see it, that our population proportion is 8.3%, and if I subtract 2% from that, I get 6.3%. If I add 2% to the 8.3%, I get 10.3%. And if you change all these to decimals by moving the decimal 2 places to the left, we get 0.083. This is 0.063, and this is 0.103. Now, here's what I want you to look at. If I shade in between these values, then I'm saying I want to know the probability that this differs by less than 2%. This area in here is going to be that it differs by less than 2%, but we want it to differ by more than 2%, which is going to be this region out here and this region out here. So we need to find z-values. And I'm going to tell you, really, there's only one z-value that I really need to calculate. I need this one down here for 0.063. But I'm going to ask you to calculate the z-value for 0.103 just as a check. Okay, since we move the same distance right or left from that population proportion, we know the areas of these two tails are the same. So if we can just figure out what this area is on the left, then we're going to know what the area, the tail on the right end would also be. All right, so our formula is p hat minus p divided by the square root of p times 1 minus p over n. If we substitute in our values, the n on this problem was 91. And as far as the other z-value, again, I really want you to find that just as a check. The one on the top, the 0.063 minus 0.083 divided by the square root of 0.083 times 1 minus 0.083 over 91 is going to give us a z-value of 0.69, excuse me, negative 0.69. And this one is positive 0.69. Again, the only one I want you to look up is this one, because that's going to give me this area to the left of z is negative 0.69. Again, I ask you to calculate both just to make sure we didn't make a mistake. So if you look up z equal negative 0.69, you're going to find that the area to the left of that is 0.2451, which makes this area on the right tail the same, 0.2451. So we can actually take a couple of ways to look at it. I can either add those two, or I can take 0.2451 and multiply by 2. Either way, we get 0.4902. Again, this is central limit theorem with proportions. And again, here's our formula for calculating z. I'd like you to do problem number 3 and send your answer to me by email.